Hi, this is Ronnie Chaudhary. I'm the Director for Center for Connected Multimodal Mobility. It is our pleasure today to welcome Dr. Gurcan Comert. Dr. Comert is an associate professor at Benedict College and a great collaborator for our center. So Dr. Comert works on risk analysis of transmission systems, especially intelligent transmission systems, through the development of applications of statistical models. He's also involved in the modeling and quantifying of cyber attacks at transportation networks under the framework of connected and autonomous vehicles. And I have worked with Dr. Comert in this area, so he's actually a leader now on cyber attacks and its prevention for connected and autonomous vehicles. He has developed several models, including change point models for cyber attack detection and prevention. He has published in top peer-reviewed journals and conference proceedings. He is an associate director of our center. He teaches graduate and undergraduate courses in mathematics, statistics, and computer sciences at Benedict College. And he has been involved in significant research in transportation systems, ecosystem, eco-driving, as well as cybersecurity of intelligent transportation systems. So it is our pleasure to welcome Dr. Comert.
Thank you, Dr. Chaudhary. I appreciate for the introduction. So, so today's topic is basically our experience out of the collaboration with the center projects, and then how do we integrate these research into classrooms in a very, very broad way, to put it, as our kind of approach. But specifically, we adapted a pedagogical approach from University of South Carolina with the collaboration, which the names I'm going to include them. Hopefully, if the presentation goes well, we'll see these, how these are possible. Basically, we'll see those names also. I'm going to acknowledge each individual that I'm working with. So this is also so basically hand-to-hand with the a NSF project that we were awarded from HBCU program. From NSF, and then also our center obviously supporting us greatly. So okay, all right, so I would like to introduce first the Benedict College to basically attendees, audience from outside South Carolina. Benedict College is established, founded in 1870. So last year it was the 150th year of the Benedict College. So it is a private institution, is one of 8 HBCUs, one of the 8 HBCUs in South Carolina, and one of the 101 HBCUs in the United States in general. We do serve to all 46 counties in South Carolina and 30 states across America. And then we do offer 34 BS degrees and 1 master's degree in supply chain from business school. And we do have actually an equal male and female student population in terms of diversity. It is as well balanced. Our student population. So objective of this particular talk is we've been having we've been having some thoughts so how we could actually deliver the critical skills that we in general from you know, when we basically expose ourselves to research, we do find out, you know, things are changing. Obviously, technologies different technologies are coming up. Emerging technologies are. What we wanted to do better equip our students, and also in existing classical skill sets that we know of, simple as mathematics from calculus to principles of physics. So how do we better deliver these concepts to our students? And also with these emerging technologies, so how we can actually meaningfully integrate some of these concepts into these classes. So that was a really kind of broad idea that we wanted to have this. And throughout our conversations with Dr. Huyn, and then his colleague from University of South Carolina, Dr. Pierce, so they actually have been doing this in different technologies or different emerging research areas, such as nanotechnology. So they've been doing this approach of effects, which I'm going to expand in a little bit. So they kind of introduced this to us, and we were interested, and we went with a proposal. And the majority of the presentation that I'm going to show today are coming from these two conference papers that we actually presented in ASWE. So on this talk, though, I would like to share my experience, our experience in general, and then kind of maybe this would give some idea about how emerging technologies would be kind of thought or integrated into fundamental or maybe even gatekeeping courses. Although not all courses, obviously, but maybe they can give some idea. Again, how we would be able to deliver these critical skills. And then in our proposal, mainly we were going for curriculum, obviously, kind of revising our approach to courses. But then we are doing research at the college too, and we are collaborating with professors like Dr. Chaudhry. So then we said, okay, can we actually come up with a structure to really integrate this into the RU setting? Sorry about the typo here. So could we be able to go ahead and then deliver some critical skills in an RU setting too? So in the objective of the project then, it was really improving our teaching. It kind of gives students some experiential learning, and also kind of integrate this into curriculum. As we can see from this picture too, that we also wanted to, in general, Dr. Pierce was doing this. I'm sure Dr. Chaudhry, they are also doing this, but I was not at the time familiar that the PhD students are being also kind of brought into these pedagogical approaches, new pedagogical approaches. So they would be, when they graduate, they would be ready for really, challenging classroom environment, because it might be a challenging environment, certainly, depending on obviously classroom population, but at the same time, obviously cohort to cohort, these can change. But then as a small college like us, another thing is really, we are saying that school of STEM, right? So we do have a school of STEM, for instance. We used to have, now school of art and sciences. We do have many majors that we are working together. We are generating or developing curriculum together, but how meaningful we can actually kind of get students from different disciplines, and then maybe introduce our research area concepts, or maybe skill sets from our perspective research fields. So that was another idea, that within an interdisciplinary environment, heavily interdisciplinary environment, so how we would be able to kind of generate some problems that will kind of benefits, so students will benefit out. So this methodological approach is really a problem-based learning. It is out there, we know that, but then obviously, as many problem learning kind of approaches, methods, this is kind of challenging for instructors. So it really needs careful design. So in a very simple pedagogical terms, we could actually present our approach. One thing is that we wanted to kind of have students to redefine some of the problems. Okay, so we do actually introduce or design a problem, and then we let students to really, from their basic knowledge, whatever they have currently, to redefine this this problem. And then we wanted them to really, throughout the activities, to reconstruct this problem. So as we learn, as we kind of experience this classroom, and we introduce different skill sets, we introduce different concepts, then they basically reconstruct this this problem. And then again, at the end, what is happening that we do reconnect everything, because this again is a regular classroom really experience. At the end, we are delivering the essential concepts to students. Then they reconnect with the original problem, and then they basically realize that how much they were able to kind of whether they did or not, they were able to kind of experience out of this class. So in terms of the activities, they are not necessarily all hands-on, because again, the nature of the class, they may not have to be hands-on. The only thing is that really they need to have problems. We need to be able to generate some problems that they will have kind of they could be able to put their minds on, kind of and then kind of think critically on those problems. So the approach called effects, which is the environments for fostering effective critical thinking. Now, so the approach is a modular approach. So what we are really doing, we are coming up with this big problem, this very relevant problem. We have to really design that. And then we are developing activities around that problem. Step by step, we are introducing also critical concepts. And usually these are like 5 to 6 classes, depending on class duration, class sizes, because it is really heavily using group activities. And then obviously we are connecting everything together. So careful design activities around a big problem and giving these concepts to students. So overall steps are, as we can see here, and we do need to come up with a driving question. So I'm going to give some examples that what we came up, and then basically we design activities around, and then like I said, the final design, and we are finishing these. And then obviously this is a part of a semester; it's not the complete semester, so at the end, it is really the only thing is that we need to be able to, in a comprehensive manner, we need to be able to kind of visualize and then guide students throughout this experience. So what we did in applications, implementations, we started with 3 courses at the college initially. Then Dr. Ismail Abuduma actually joined us. So we started with Introduction to Engineering. We had the air quality in the environmental health science and environmental engineering with Dr. Samuel Darko, and computer science software engineering class, Dr. Balaji Iyengar. So we started with these 3 courses. And then So you can see that the class sizes are, in my case, the engineering 110 had 36 students in two sections, and air quality had 6 students, and then Balaji, Dr. Iyengar had 12 students there. So some classes are more advantageous to be able to have small groups and then introduce them some, activities, even bringing them outside for different activities, as Dr. Darko did with his students, running drones, kind of loaded with air quality sensors. They did this actually inside the gym too, for the indoor air quality measurements. And then Dr. Iyengar actually in his class, so he also used kind of drone related user interface development in his class, drone controller development. And in my class, we actually kind of looked at a problem of emissions, calculating actually emissions due to circulation. At this time, actually, the college's enrollment was about 3,000. And then on campus, we were getting a lot of traffic, actually, especially in the morning. The faculty and students were circulating a lot to be able to find a parking lot. So it was a relevant problem for them also to be able to kind of relate themselves. So again, Introduction to Engineering is basically a general course that our engineering students are getting. Computer science, some of the computer science students are also getting. At that time, it was 1 credit course. General concepts are being introduced. But then physics majors, roughly any STEM major really who needs a credit would be able to take this course. Therefore, we kind of wanted to have a problem that is going to be within transportation domain. Obviously, I want to kind of emphasize that all our faculty that we were collaborating throughout this research, they were actually kind of relating themselves to transportation problems from their courses, which is not always straightforward. So the air pollution control in Dr. Darko's class, so he looked at the environmental impacts of emissions. He goes deep in pretty much the VOC's different concepts there, but transportation sector, it was actually one of the concepts that he was showing his students. But then, with this project and then kind of approach, he was able to kind of revise his approach. And also kind of come up with some design and structure to his course. Similarly with Dr. Iyengar. So and obviously the good thing with this is we were able to also kind of with the help of our center, C2M2, our center, we were also kind of work on a project too at the same time. So the students, some of these students obviously who were interested, were actually also working on a project, which was really the air quality measurements from sensitive zones, so school zones or work zones. Similarly, we kind of how we would be able to measure, and we gathered some sensors and we were able to connect them. We designed some stations, we calibrated them, all these steps, and then we were able to deploy them to the elementary schools, as well as we actually deployed the sensors, the stations many times, actually different parts of the campus, Benedict College campus, which is an urban campus. So it was also related to, quite relevant to them, and some of our students actually had basically kind of respiratory related kind of symptoms too, some problems too. So it was actually kind of relevant. So in terms of impact, so what kind of impact, what kind of class sizes we are really looking at to basically out there later on how people can see, researchers can see that, you know, whether obviously large colleges, they do have actually large class sizes. It may not be really appropriate, or it might be appropriate for basically low number of effects, kind of effects activities. So that's again is a design issue. But here in our case, the largest class size that I was working with was 25, and then regularly actually we have these activities you know, with students. So we had these simple activities. Basically, if you are going to, you know, in class data collection, we did again we had students to really look at kind of platoon design, and then those kind of research concepts brought into the classroom, which I'm going to talk in the research concepts there too. By the way, I'm showing some actually pictures here, but these pictures are not really all summer activities. All of these pictures obviously before pandemic. So that was, you know, heavily, we were really having our students to travel, field trips, these regular seminars, any kind of activity that, especially from center, I need to emphasize that we were actually having students to participate in that. So we do see Dr. Chaudhry, so he had several spring kind of talks at the college. Some of them were online. So that's one of the online conferences, webinars that he provided us for in cybersecurity. And then we do see actually some of the cybersecurity students, director of the cybersecurity over there, Dr. Jitter. And then we do see in the below the picture at the bottom, that is actually from a fall conference, again from C2M2. We took our students to actually one of the training sessions there. So these are all happening. So we do have these transportation concepts from classes. So we try to kind of expose our students to as many topics as much, and then we'll see, you know, what happened then. The environmental engineering, Dr. Darko, he is basically, so he's my friend obviously, but he's basically a hands-on professor. Already he has like 3 labs that he's running, materials lab, for instance. Then he has some other instrumentations, as well as some air quality related you know, measurements lab. So he's already a hands-on person, but then obviously he designed for specifically for our project, so solid waste management kind of related project, and then he thought about a kind of landfill land space for a certain population. So in this case, it was Benedict College plus University of South Carolina, since we are nearby. So they were actually coming out with what kind of landfill that would be needed for 50 years. And then he also looked at the, you know, kind of, again, as an urban area, it is different population characteristics, let's say, throughout this city here. So he was able to also kind of generate a problem, the students to look at kind of solid waste littering and the socioeconomic factors. So he was able to actually generate another problem like that. And then he went ahead and then generate another indoor air quality related problem too. We do see actually Dr. Petrulis, our kind of consultant. So he has been helping us a lot, interviews, kind of reflections from students. All of them are professionally done. So he actually observed all of our beginning and then ending kind of decision worksheet activities. And then obviously, as we can see here, Dr. Darko kind of had our students to really also take some real world measurements on campus. These are, we can basically say on campus traffic plus air quality measurements. In the software engineering, so again, Dr. Iyengar went ahead, designed this drone controller, kind of user requirements, etc., from his class perspective. So in his class, and then as you can see that we did actually throughout this, with this similar with these students pretty much. I can basically name these students here. Hohite. So she was actually partly in Clemson. So other students here I can name that. These students actually we also worked with them in the research too. And as you can see, one of our students in our project starting meeting that we do involve. And Dr. Abiduma, 1 year later, he joined us. So, and he immediately started actually kind of implementing in his classes, digital logic, then later on communications, etc. So, so he adopted also this effects kind of framework in his classes. And then he designed kind of logic gate for parking garage. Students actually kind of they generated simulations in design project classes, and they used also kind of our equipment too, which are these simple connected kind of vehicles. So they had them also kind of work on those vehicles too. So that was all connected kind of collaboration. So how do these decision worksheets kind of look like? I mean, it really takes some kind of thinking, some design. So in my case, we can see that. So what we are really looking at here, students to be able to kind of, again, it is really redefining based on their understanding, right? So in my case, for instance, I would be able to maybe relate this to the time. So we do have actually kind of rush hour concept there in the beginning, kind of in the morning. Then it's going to get eased. It's going to be eased. Then we know that maybe it's going to be another peak, etc. So and then also we do have designated parkings for faculty, students. So these are all kind of some factors they would actually kind of impact this. So we wanted students to be able to think those, identify those critical factors. They would kind of list those, and then how we are going to collect data, etc. And then are they going to be able to using some simulation to be able to identify whether we need additional parkings or revision of designations. So, but what was the really question? The question that they would be able to relate and then kind of summarize this. So what is the total empty spot search time in hours per weekday? So that kind of a number that they would be able to come up. That's our kind of purpose, that they would be able to come up, how many hours really being spent there, so they can relate them to gas, person time, emissions. It would be able to kind of see that, oh, that's huge. So, if I assume these, right, and then if I calculate this, then I would be able to. So something that can be calculated, that, class duration or activity duration, this decision worksheet activity duration, and then they would be able to come up with some sketches, etc. So again, in Dr. Darko's case, so this was the first decision worksheet he designed. That was, again, municipal solid waste kind of, so around the campus. So our idea was really kind of from our side, kind of just getting the drone up and then see improperly kind of thrown left wastes around the campus, around our building actually. So they would be able to see, and then they would be able to kind of show that. And then he also came up another design, another worksheet, which was by just looking at this traffic there. So what would be really the CO2, carbon dioxide emissions? So in that case, the question would be, from the image provided above, determine the gallons of fuels gets wasted and the pounds of CO2 released into the environment every day on this particular roadway. So that's kind of, again, without any kind of prior information, the idea, the students to really kind of to come up with this, and then, you know, these concepts will be given to them, and then hopefully they will be learning to basically approximate maybe in this case to really come up with emissions or, you know, fuel consumption. We know that this is mixed traffic over there, different vehicle types, etc. So, but what happened when we did these? So when we implemented these classes, obviously mixed reactions, right? So we are first time doing this, and then we wanted to see Dr. Petroulis help us to really do these interviews. You know, what students were able to kind of tell us back. So according to the students, so these are some of the actually kind of almost reverted kind of feedbacks from students. So first things, one of the first things that the students liked, in my cases too, I've seen that. So there is no penalty, obviously, in decision on these decision worksheets. Later on, activities can be with kind of grading, obviously. But the decision worksheet is really an open-ended, really kind of thought-provoking, kind of get them to critique, to try to come up with freely these kind of factors or solution. So they like that. So they like that to be able to kind of think freely and then focus on that. So again, it was giving them some incentive for problem solving, process and reasoning. It kind of also gives them the sense to, you know, like roughly what do they need? Also, for instance, in my case, Introduction to Engineering, also it shows students that what is really expected later on and throughout their majors, right? So as an engineer, as a problem solver, so they need to be able to kind of come up with, to be able to challenge these kind of problems. So some, in my case, I've seen some of the students that they were not really interested in kind of working on these kind of problems. So it kind of as a gatekeeping course in a way, also guided students, some of the students that maybe, you know, this realistic problem is not going to be their kind of, you know, aim or goal later on. So it also showed them. Again, this was in a way, it was an experiential learning, and then it allowed for a before and after comparative analysis of thoughts, obviously, and knowledge acquisition based on students' individual group work results. So yes, so as we develop activities, as we actually kind of conduct these activities, the sense of really, you know, these sparking moments really kind of appeared in the students. So we were able to sow those. We were able to see those kind of you know, moments. So another thing that kind of for instructors' point of view, we were able to give them more real life, and then also we were able to relate to our research, some interesting problem also from our side and too. We also kind of we also saw some challenges. So these some of the challenges, obviously, you know, from our side, it's really design is time consuming, careful design is needed. So really we need to be careful not missing any critical concept there. So those are the challenges. It is really kind of a little bit heavy on instructors, but once get used to. So maybe again for my case, it was, you know, like first implementation, it was difficult, but later on as we get used to, so kind of in my case, I was kind of adapting or seeing things, the delivery things actually from this perspective. So, you know, like the goal that I have in my mind, the specific goals that and then I was kind of wrapping these problems around those. But certainly the students also had some concerns about like these group activities. That's always challenging to, you know, some in a group activity, obviously some students are taking initiative, some of them are not really kind of working all together. And then, you know, so maybe it's not really a pleasing kind of experience, you know. So that's kind of some of the feedback also we got from students. And obviously, although in kind of design, it's not really hands-on, it doesn't have to be, but we do try to come up with some also hands-on problems as, you know, kind of part of the effects approach. So another thing is from students' perspective, for students really, you know, direct delivery is kind of the practice. They've been kind of they've been seeing this approach, you know, kind of direct delivery. These are the concepts, they've been learning this, and here's the quiz or test, and then they are kind of basically getting. So maybe some of the actually better students kind of, you know, asked the question already kind of approach was there too. I did have some feedback like that in my classes too. Some of the students were, so what are we really kind of, some efforts from their end too, kind of, it was a little bit confusing at the beginning, but obviously kind of we were able to later on then compare, saying, asking students really, I mean, was that really kind of a good approach later on when we kind of evaluate this? Because although we were only kind of 4 instructors are doing this, but one of our objectives is also kind of have other professors kind of like this seminar, we would be able to involve other faculty too. We do have some ideas in mind to really kind of bring in wherever students are challenged, kind of having some problems. We would like to really kind of have this approach, and then let's see if we are able to kind of, improve. All right, so again, some of the students had their kind of frustration with the quality of their groups. Like I said, many of the time we don't even know students. If it's a large group, it's not always really easy to pair or put students in groups that they're not going to have kind of a uniform experience. All right, so again, from our side, it is really time consuming. It is really, at the beginning, it is really hard. So we need to really kind of design a lot of things at the beginning. Later on, it gets easier, but we need to be careful. This is only in classroom. We are already doing this teaching, and then we are just slightly manipulating our approach, putting in a different structure. Now, the question, which towards the end, so the question is really, we are in an undergraduate institution. We are in an HBCU here at Benedict College. So we do have REU experiences. Now, summer research experiences. So we thought that, you know, how we would be able to design these REU experiences. Again, this is a kind of a test design, so that students would be able to better kind of get experiential learning out of the summer research, and then see if indeed it's going to be more beneficial, or you know, we wanted to kind of see ourselves whether we can design some such thing. That was idealistically, we thought about this, obviously not really knowing that how much time it's going to take or not. Our concept is disruptive technologies. Disruptive technologies are really kind of coming in very interdisciplinary kind of, it can be very interdisciplinary. We know that it is really transforming technologies are disruptive technologies. Autonomous vehicles is one of them. In 2009, we thought about this, but in 2018, for instance, I'll talk in a minute, that we were not even able to get there. But platooning of autonomous vehicles was our kind of umbrella topic, and we explored different concepts there involving different majors, different background of students. Now, again, the idea is from these summer research experiences, we said, if first of all, I've been actually involving in RUs at the college since 2011. So all these years until 2017, the classical approach. So we do have our research agenda, and then we are bringing in some interested students that we know from classes, somebody maybe kind of recommending. So we were getting these students, and then we are basically, along with our agenda, we were involving these students. This is the experience. So students are, yes, so they do write code, they do basically prepare presentations, they do write manuscripts, etc. So this was happening. However, what else we could be able to do? What else, how we could be able to empower, how we could be able to enhance this experience? We said that. So how at the end, I mean, is that really the experience that students is really like a critical thinker? I mean, is that really student is really kind of communication skills or teamwork skills? Are they really being developed, you know, in that kind of experience? From my background, at least, maybe not. So I did have actually some difficulty. I had mixed kind of experiences there. So I had like award-winning, again, in within the obviously the summer research experience, award-winning presentations versus dodged presentations. So I had that. So students, you know, they were very stressed. Some of the students, the concept is heavy, for it's very technical. Then, you know, students was not able to present. So those kind of experiences. Then we went into this design. Our approach was really kind of break down to this experience, to basically problem definition. Then from this problem definition, come up with assumption and approximations. Then have some, again, activities, develop activities, which many of the time, Dr. Chaudhry, Dr. Hoin, our center, actually, they helped us. So we actually give these to students. And then at the end, we were able to kind of deliver some critical skills to our students, which I'm going to show in a minute. So again, some group activities, etc. So we had two different experiences. 2018, we started with the RU experience, you know, having this our approach, effects approach, I can say. In the 2018, we heavily used University of South Carolina's kind of the RU workshops. But then Dr. Pierce, thankfully, he actually kind of designed for us some kind of problem definition sessions, and then kind of assumptions, approximation, problem almost like reduction kind of workshops. So he developed and then kind of delivered these to students. Literature review, these were all activities throughout this summer experience. Now, in the first summer, we had 2018, we had 8 students. They are coming from mathematics, 2 students from mathematics, to computer science, computer engineering. More or less, some of the students were second year, actually one of the students were only a second year. And then majority of the students were actually first year researchers and then kind of exposed to these concepts. So what did we do with them? So I wanted to, yes. So these are some of the activities that we kind of gave them. The activities were mainly problem definition. So library use, again, active learning of assumptions and approximations, research as process communication and communication workshop. And then the others basically kind of research ethics. Both REUs actually had the research ethics workshop. students were actually kind of exposed around these concepts. So when we consider, majority of them are really not technical. So I mean, in terms of particular to their research, so it's nothing kind of particular language. Yes, I kind of help students, introduce them many concepts in terms of give them the R concepts, some Python related scripts. I gave them. We basically did those together. However, it was not really kind of within the kind of activities. So that was our first 2018 REU. In the 2019 REU, we had 7 students with biology, environmental health, science, mathematics, computer engineering, and computer science. So a little bit diverse now. Again, all of these in selections, by the way, students are declaring their interest. So we are recruiting, but we're not really kind of, again, with the project or projects, we were actually kind of little bit free to be able to kind of have our students, different diverse background of students. So we were not pressured in a way that the outcomes are going to be, like the cutting edge, this, that. No, but that was really an experiential learning for these students. So that was our priority, from the beginning. So what did we do then with this group of students? Again, Dr. Pierce delivered some workshops right from the beginning. We actually designed a decision worksheet. The decision worksheet looked like this. Okay, so it looked like this. So this was really, thinking that the connected and autonomous vehicles are going to be a way of basically alleviating, reducing the bad impacts. So suppose that's the case, right? So one of the applications is platooning. So if you're able to achieve this, so what would be kind of the full consumption reduction, emissions, per vehicle mile travel? So that's kind of as a very broad, open-end research question, obviously. As you can see here, the units, actually, we wanted to kind of have students to really think about that too. Then we wanted them to really identify like some important factors. We wanted them to really kind of envision a platoon. We have a biology student, so how is that going to be envisioned? We do have an environmental health student who has taken actually at that time, who had taken the air quality class. So he is familiar with these units and etc. But how about in this case? And then we have mathematics, let's say, student, but is he, for instance, is familiar that how this platooning, maybe from air drag or the cross-section area from perspective, again, is the maybe the formation perspective, the how this is going to be kind of platooning is going to be reducing these emissions, and other, not considering others, this control issue, obviously there. We computer science students who used to be a kind of doing research in cybersecurity, again, the stability there, all these concepts. Then we kind of taught some activities. So the first activity, obviously, is the introduction of the decision worksheet. Then this is the overall. I wanted to kind of give you the list here. Yes. So the activity 1 was really the in a very short and simplistic manner, was sketching the platooning. So how that it could be actually a concept. Then we wanted students to really look at from, can we actually approximate this behavior from other biosystems, right? So the nature, from nature, would they be able to come up with anything that would resemble to this activity? And we know that a lot of researchers are doing those kind of mimicking from nature. So they did. They looked at from literature until the end, actually, that continued. We had Dr. Pierce's assumption approximation as kind of within a Fermi kind of problem. Students worked in smart pi vehicles to control. Actually, these are some of these concepts are also within their research track. So a student maybe from throughout this summer, although it's one of the activities, but worked on the biosystem. So, you know, another student really looked at the control of this pi vehicle through different sensors. And in fact, student was able to actually, using simple feedback control, was able to actually control stable control this vehicle, and then was able to move that vehicle on a straight line. Otherwise, we know that these simple pi vehicles, that depending on this reflection from this ultrasonic sensors, it was really kind of wiggling. So he was able to correct that because he added more sensors, etc. And obviously there was a feedback based on. Then later on, we started with the help of Dr. Uddin there. So Majba gave us several Python coding kind of sessions to our students. So our students from biology to other majors, all of them environmental health science, their mathematics requirement is not high. So but it was very, very nice that all of these students actually were exposed to these coding exercises. And obviously they were in the group of 2. They worked together. So they kind of dragged together to achieving this common goal. At the end, we were able to complete 10 activities. And then the research teams were like intrusion detection from one of the students, computer science, sensor fusion, and smart card. So one of the students actually worked on that, had many different sensors actually he used to be able to control that vehicle. Air drag reduction from platooning. One student worked on, 2 students actually worked on that. Another student in environmental health science worked on the air quality estimation, used the simulation from FASTSIM. And then again, biology student, biosystems, and then another student worked on the image processing. So these were kind of, again, some of the things, some of the research that the students actually worked on. I need to quickly wrap up. So so what we aimed, honestly, we really looked at these activities really focused on different disciplines. So overall, obviously, we are working on a transportation problem, but it's a multidisciplinary problem. We had, again, the biology to physics. We had, they looked at actually kind of some exercise. They looked at from these vehicles, kind of they were able to look at not really clear acceleration was given. So the input they were able to kind of find out these acceleration values. The RPM speed, they were given in kind of a unitless fashion, in kind of specific rates. They were able to figure out all those by just actually kind of conducting some experiments there. They had, again, traffic signal coding in Python. Control game was really, again, it's really from simple speed control to acceleration, speed change, the acceleration, simple constant acceleration, and then the varying acceleration, jerk then example. They looked at those, and then were able to see how control is really kind of becoming more complex. Then they looked at VSP from, again, moves. They were able to code these, so different vehicles, right? The speed profiles, they were able to get those operational modes, and then kind of derive some, write some functions in Python to be able to, derive those. And at the end, they were able to realize once we give this decision worksheet, obviously, all these activities, all the discussions, they were able to kind of much better visualize, much better define this problem later on. So this overall, we had these kind of specific for computer science students, or all students actually having the script writing experience. Again, computer engineering students for control, logic, kind of skill sets. So what I would like to do, I would like to finish since I'm towards the end. So overall, our from student reflections, students reflections, obviously they like this experience. So the experience was not really kind of all pressured. We were, I spent a lot of time. I get a lot of help, obviously, from let's say Majba, Zulfikar. So I'm going to just put their names there. But overall, maybe I should just quickly summarize this as this methodological approach, the structural approach to REUs might be very, very valuable. In terms of cost, when we consider this involvement might be a little bit higher, but still in terms of overall experience, it was very, very kind of beneficial. Students mentor involvement is high. Obviously, day one, all the time I was with them. But like I said, I got some help. The major theme emerged from the student response is that they had become much more self-directed autonomous learners who said they enjoyed both challenge and the teamwork they had experienced during the RU. Yes, they were in teams, and then they really kind of were thinking from day one. So overall, we've been having regularly these students, about 11 students. Regularly, we are interacting with them. And then we had these 5 students graduated who involved more or less in the activities. Some of them are more. Some students are working in Google as a software engineer. And we have actually Bright, Quentin, Ahmed, they're all actually going for their graduate programs in civil engineering. Particularly, all of them are actually in transportation. So that's kind of, I guess, from environmental engineering to transportation. So Ahmed from environmental engineering to really pavement. So he's working on that too. So we really kind of had our students to, kind of transportation related fields. And here is our team. I kind of mentioned their names at the college. Here is my collaborating team. So Dr. Pierce, Dr. Hoin, and Dr. Petrulis. Zulfikar is is my friend. So he's in education. So he is from Pedagogical Approach. Helped us a lot to put these all in framework. Great help. Majba, he had again, he's now in Oak Ridge National Lab, so he helped a lot again. And Mohammed is recently, so he got his PhD, and he is also helping us to kind of summarize what we've been doing, what we've been collecting. So data collection is kind of also from our experiences, our habit too, but it's not really only this group. Dr. Chaudhry, Dr. Rahman, Dr. Khan, Dr. Wakalenge from AC State, and Dr. Minchalaka. So Jadid, Mahfouz, Charlotte certainly has been kind of helping us with the activities, all this, and then other UTC PIs. Because as you've seen, Jadid, Mahfouz, they've done a lot of help in terms of kind of giving us trainings. So all these activities, and maybe this is a fairer collaboration network. So really throughout these research, throughout these activities, we've been interacting these groups. So the PIs, when I say PIs, only one line, but is really kind of expands to all this network. So in terms of future, we would like to summarize our kind of virtual experience in same fashion. What were the negative or positive kind of reflections from students. We had actually 4 groups then last summer. We're going to see for this summer what's going to happen. Again, we do have some concepts that we need to come up with a problem for either classes or summer research. And then in terms of another activities going on, the quantum lab is being Saqib is is helping us, and Dr. Khan. So he saw right now, what kind of things were pedagogical things that we're considering. So he is going to actually help us to work on, in the quantum lab fashion. So that's one of the emerging technologies, right? So we're gonna hopefully develop together some decision worksheets within that. Then again, I need to acknowledge that's NSF HBCU UP grant, and also our center, C2M2, have been helping us. 2007, I had actually summer research with the Department of Homeland Security. And yeah, this, my findings is obviously not really representing the agency's thoughts, but obviously I need to acknowledge that without this support, obviously we could be this much free. Okay, sorry about being over time. If you have any questions, I would be happy to try to answer. Thanks for your patience.
Thank you, Gurcan. It was a great presentation. So thank you so much. So now any question you can write in the chat box, or you can ask.
Okay.
Just unmute your speaker. Any question? So I have a question while we wait for from the question from the audience member. So so you have done some analysis on the impacts, right? So that the approaches you are taking, I see that you will be doing longitudinal study, but do you have any initial data how effective the things that you're doing were, and what were the most effective strategies?
So that's Charlie, we did not actually yet put that as you said, like in a time longitudinal study. But initial, how can I, the thing is, with our students, I believe the most important factor is this kind of self-efficacy, I think, is the most impacted one, meaning that the students are not being intimidated by the research topic.
Okay.
That's one of the things, that was most beneficial out of these research these experiences overall so far. And then graduate study, for instance, yes, when we did research together, and then if we do that research, like from my perspective, providing the critical things, that maybe did not break that barrier all that much. But when we kind of give them this incentive, kind of guide them through this experience, they were also kind of less hesitant to going for graduate study, like seeing it as a very, very difficult thing. So that was also much more higher.
Okay.
What we observed. I think I had a kind of, I can show some numbers here. Right here, I had this table, and then we can show that the graduate study, right? So in this, for instance, 2019, so we do see 80% of them would be considering actually the graduate degree. These students in this cohort, I had only one international student.
Okay. Okay.
So
yeah, I think some of the things you're doing are actually really good. So if you find those to be effective for your students, so this could be a national model, right? So I think this would be very good.
Yes. Yeah, the improvement, it certainly it can be improved, and it could be like a habit in terms of like putting these RUs in a structure, immediate structure, and then kind of identifying these skills and emerging from emerging topics. That could be excellent. Yeah.
Yes, so, and we are working together now on the quantum AI lab project.
Absolutely.
I think that would be also very useful for all of us.
Absolutely. That would be excellent actually to really have it and put in this framework and then, share our experience together.
Thank you. Thank you so much. Any other question? Saqib, I see you have a question.
Yeah.
Yes, so I can read it out to Dr. Comert.
Yeah.
So first of all, thank you, Dr. Comert. It's a very good presentation with so many great examples. So I just wanted to know, like, so the undergraduate students, they have a pretty limited time with all their other course commitments.
Right.
So how do you think that we can utilize their the whatever time they can manage beyond their coursework? How do you think we can better utilize them as a research asset in, let's say, in a year-long project or multi-year projects? Do you have any observation?
So the one thing that I kind of find from the undergraduate students, since we do not have graduate students, regardless, they have their own object, kind of goal. That's I've seen. So no matter what we are kind of giving them as opportunities, certainly they have their own career plans. It's not like graduate students, advisor, and then there's a track, and then there's constant communication. That's from undergraduate students. That's understandably, it's more freedom there in terms of their kind of, you can always escape and then leave, go for other experiences, internships, and this that. But from it's actually a good question. How could we be able to better utilize their kind of the engagement in terms of one of the incentives, obviously, that we couldn't do was, this is a part-time experience, so it's part-time. We were able to, we did give them some payment incentive, obviously. They are doing some work out, and it's nice for students to really kind of to be able to give back. But regular, so having that as a kind of a regular kind of a payments at the same time, that putting that into a nice structure with the hours is also very, very beneficial. We could not actually do that all that regularly due to we need to think about this as like, this is also happening in the kind of teaching load too. So, but if there was kind of admin responsible, from our projects, let's say, and then taking care of those sites, I see that it's actually for students, kind of they're able to, regularly, they are regularly actually participating. I know that because one of the important concepts, especially from our students, is that they do work outside. They do work outside, and we are trying to bring them into the campus. But then again, it's something is regular over there outside versus, if we are even lagging a little bit, then they do prefer actually kind of regular payments, etc. So it's as expected, it's not really immediately seeing the benefits and advantages. So that we need to kind of realize those. So,
I have a quick question or comment. So, Gurcan, at Clemson, we have creative inquiry. So students can take these research-based courses for 1 to 3 credit hours each semester, and it can go for the whole 3 years to 4 years. So something like that, where they can take a research-based course, say for 3 credit hours, and then or 2 credit hours, and then they get credit at the same time they do this type of research. So that could be something like a solution, right?
yeah, that's actually excellent, actually. I did not know that. Yeah, I knew that the senior design project, but the creative inquiry just regularly continuing. They could take every semester. That's excellent suggestion. Actually, we should consider that in our curriculums. I'll bring that into actually our department. Thank you.
Thanks for answering, Dr.
Thank you.
Thank you, Gurcan. So I don't see any other question now, I think. So it was very, very good. I really appreciate you doing this, Gurcan. So thank you. Thank you. It was extraordinary. Thank you.
Thank you very much, Chaudhary. Thank you very much for the invitation.